My name is Takashi Koide. I'm going to talk about our paper entitled "It Never Rains But It Pours: Analyzing and Detecting Fake Removal Information Advertisement Sites." I'd like to start with some background about the fake antivirus software and its distribution path. Fake antivirus software pretends to be legitimate antivirus software and is used to manipulate users' devices or steal money. Fake AV software is a traditional threat on the web, but it's still effective in spreading malware and PUPs. To distribute fake AV software, hackers used various techniques. For example, they take advantage of online advertisements which typically show fake virus infection logs, and they also show messages claiming the necessity of installing fake AV software. Driver downloads, spam emails, and software bundles are also used to allow users to install fake AV software. Have you ever seen a website like this? This website introduces the malware removal guide and suggests antivirus software, but the link below actually leads to fake AV software. We focus on such malicious sites as the new distribution channels of fake AV software, and we name them fake removal information advertisement sites, or fraud sites in short. Fraud sites provide fake removal information by using the names of specific cyber threats. They not only use malware detection names, as you can see in the example, but also use malicious domain names, unwanted browser extension names, and fraudulent pop-up messages. The purpose of fraud sites is to lure users to download and install fake AV software. Let me show you a threat model of fraud sites. Victims of this type of threats are users who have already suffered from security problems such as malware infection. First, users try to search for removal information using specific cyber threats. For example, how to remove plus a malware detection name. And they access fraud sites from search results. Then users will lay fake information on fraud sites and follow instructions for downloading fake AV software. Sometimes the installers of fake AV software are downloaded directly from fraud sites, and sometimes users are directed to software distribution sites of fake AV software. Finally, users install fake AV software and make the damage even worse. The point is that fraud sites exploit the psychological vulnerabilities of users who require removal information for cyber threats. There are some studies that analyze the case studies of fake AV software distribution from social engineering aspects such as fake virus infection logs. However, no previous study has focused on fraud sites. What we tried to do was to develop a system to automatically crawl the web and detect fraud sites in order to understand the ecosystem and the risk of fraud sites. We also reviewed how prevalent are fraud sites on the web. Before I explain our methods, I briefly introduce the common page structure of fraud sites. Fraud sites often include a phrase related to malware removal in domain names, URL path, title, and text content. For example, how to remove malware from a PC and malware removal guides. And there are download buttons leading to fake AV software which fraud sites recommend. In order to pretend to be legitimate sites, attackers place logo images of security vendors and software certification companies. There are also packaged images of fake AV software. These images may be shared between fraud sites. Our system consists of two steps: web crawling and classification. In the first step, the system accesses candidates of fraud sites and collects browser-level information. Then the system extracts features and identifies fraud sites using a machine learning approach. Let me explain our system in more detail. We implemented a web crawler that collects and stores browser-level information from web pages. We chose Selenium to automate the real web browser and used Chrome DevTools API to monitor network traffic. That's when API does not handle directory. The system collects information such as screenshots, HTML source codes, and HTTP traffic. We use those kinds of information for the next classification step. Then our system extracts features and identifies flat sites. We use the random forest as a machine learning algorithm. The feature vector consists of three types of features: term parentheses, logo images, and the HTML structure. Our system extracted these linguistic and image features from HTML source codes and screenshots of web pages. Our system uses franchises of terms to capture the linguistic characteristics of flat sites. As I mentioned earlier, flat sites use terms meaning for the removal of cyberspreads in the domain names, URL path, titles, and the text content of their web pages. Our key insight is that the flat sites must include a phrase composed of 4 categories of terms, as you can see in the table below: way, removal, problem, and device. We use the number of occurrences of each term category in the 4 fields to create the feature vector. We next find specific images on flat sites. Flat sites often display logos of security vendors or Microsoft logos in order to pretend to be legitimate sites. And some download buttons are shared among multiple flat sites. To find these images, our system uses an image matching approach on the basis of our logo image database. The system extracts images from HTML elements such as image, A, and button tags and calculates their perceptual hash value. Then our system compares the values to our image database. Our system counts the number of images that match each type to create feature vectors. This slide shows 3 types of images stored in our database. Figures on the right are examples. We gather such images matching logo images, fake software packages, and download buttons from non-flat sites that we have already found, and we created our image database. I'll explain the features of the HTML structure. Flat sites often reuse web page templates, and the numbers of hyperlinks in the iframe are important indicators of flat sites. So our system also analyzes the frequencies of HTML tags and the combinations of those numbers. The system counts the number of appearances of the top 30 tags which are frequently used in the non-flat sites. I'll show you our experiment that evaluates the detection capability of our system. First, we created dataset to train and test our classification model. And by using the trained model, we tried to find more flat sites on the web. Before I show you the results, let me give you the process of creating a dataset. To collect candidates of flat sites, we used the Bing Web Search API. First, we created search queries using the specific names of cyber threats, for example, malware detection names, malicious domain names, and pop-up messages. We collected these names from security vendor sites and security community sites, and we added how to remove to those names. Then we gathered URLs from search results and accessed the web pages by using our Explorer and manual browsing. Finally, we checked the contents of each web page and labeled them as flat sites or not. In this way, we created a dataset that includes 800 flat sites and 800 non-flat sites. Here are the results of our evaluation. We conducted a tenfold cross-validation using the dataset and determined how accurately our system identified flat sites. We find our system classified web pages with a 98.8% true positive rate and 3.3% false positive rate. Next, we find more flat sites using our trained model. We use the search engine to additionally collect candidate URLs in the same way that we created the dataset, and we visited the URLs using our crawler. As a result of classification, we found more than 2,900 domain names of blog sites written in 31 languages. The total user access to these blog sites was 73.5 million visits per month. We analyzed these blog sites in detail in the following experiment. We also conducted measurement study to analyze the ecosystem and the risk of blog sites and to understand the prevalence of blog sites on the web. In the first measurement, we analyzed incoming traffic to blog sites and outgoing traffic from them. Then we analyzed the percentage of blog sites in the search results in the second measurement. To analyze incoming traffic to blog sites, we use a website analysis tool, SimilarWeb, as a source of passively collected data. As you can see the figure in this slide, we found that most users access blog sites from search engines. We also investigated the search queries leading to blog sites, and we found that the most frequently used search queries were those related to the removal of threats. Social media were also used to draw users to blog sites. Hackers created social media accounts for those blog sites and post videos on YouTube or post messages on Twitter. These videos and messages introduced removal instructions with links of blog sites. To find threats that occur when users access blog sites, we conducted an additional crawling experiment of all blog sites we found. We added a new function to click download buttons on blog sites to our crawler, and we analyzed actively collected outgoing traffic. In this experiment, we were able to find installers of 58 fake AV software families, and they were directly downloaded from blog sites by clicking download buttons. When we analyzed the transferred web pages, we also found our crawler reached 57 malicious domain names, which include distribution sites of fake AV software and payment sites that required credit card numbers and personal information. 18 of those malicious domain names were used as distribution sites for fake AV software families that our crawler didn't automatically download it. To summarize the results, we found that 76 fake AV software families were guided by blog sites. In the second measurement, what we tried to do was to measure the percentage of blog sites in search results. When you search for specific name of cyber threats to find the removal information, many blog sites prominently show up in search results. To confirm these poison search results, we created 150 search queries and we investigated the top 10 search results for each search query using Bing Web Search API. We used three types of search queries: only threat name, remove plus the name of cyber threat, and how to remove plus the name of cyber threat. The table in the below shows the percentages of blog sites in the search results for each search query and the names of cyber threats. We found 82.6% of such results were blog sites in total. Here's an example of such results when we search for how to remove plus a malicious domain name on Google. In these search results, 6 results were links to blog sites, and 3 videos were posted on YouTube and leading to blog sites or fake AV software. We found that most of such results were occupied by blog sites when users search for removal information for cyber threats, and that makes it difficult for users to reach correct information. Let me summarize my talk. In this study, we proposed a system to collect and detect flood sites from the web. By using our system, we found more than 2,900 flood sites written in 31 languages. The total user accesses to these flood sites was 73.5 million visits per month. We reviewed the risk of flood sites in the measurement study using both passively and actively collected data. We also measure the prevalence of flood sites by analyzing search results when you search for removal information of cyber threats. This concludes my presentation. Thank you for your attention.